Alright, so we're continuing techniques of differentiation 3.3. Classwork, yesterday we talked about the constant rule. The derivative of any constant is 0. The derivative of a single variable, the derivative of y equals x is 1. Okay, so there we go. The derivative of a power, x to the power is that power, you bring it to the front, times x to that power minus 1. And the constant multiple, if you have a differentiable function and c is a real number, then the constant times that function, the derivative of a constant times a function is that constant times the derivative of the function. So let's talk about e. Well, okay, here, s prime of t. And make sure you're paying attention to notation, right? So this is s. So this is, I'm now doing s prime of t, which is going to be negative 5 times t to the fourth, right? Okay, so here, let's do it one step at a time. Here I have y equals negative 5 over 3 times x to the negative 3, right? Yeah? So I'm going to bring that negative 3 to the front. So negative 5 over 3 times negative 3 is positive 5. Right? If I multiply this times this, what's negative 5/3 times negative 3? Positive 5. So I have positive 5 times x to the negative 4th. Does that make sense? Yeah? Okay. Yes?
So if you brought the 3 to the front of the x, wouldn't you have to subtract it on the x, so wouldn't it be, oh wait, yeah, no.
Just kidding?
Yep.
Okay. Okay. Alright, so letter F, this is negative 5 over 3 times, oh no, this is x to the, this is 3 cubed, huh? Over 1.
Negative 5 over 1. And then wouldn't it be 3x to the negative 3rd?
Yeah, you distribute it. So it's negative 5 over 27, right? Times x to the negative 3. Are you guys okay with that?
Yeah.
That's f of x. Because 3 times 3 times 3. Yeah? So f prime of x is going to be negative 3 times 5 over 27. Oh wait, negative 3 times negative 5 over 27 times x to the negative 4th, which would give you positive 15 over 27, which is 5 over 9, like that, right?
Is the minus 4 to the power of that?
Yeah, yeah. Is that okay? Alright, how can I say this? This is 4 times what? T to the negative 1/2. So s prime of t is going to be negative 2 times t to the negative 3/2. Okay? Which you can also say is negative 2 over t cubed square rooted, right? You should know that. Same, right? Okay, do h on your own then. Positive 20 times x to the negative 8/3.
Yep.
Because negative 12 times
get that?
negative 5 over 3 is positive. Okay?
Oh, you're laying on a little bar?
Yeah.
Are you gonna go to the Dominican house?
No.
one of
You're good, like, so much.
7 rules we're gonna learn in this lesson. But there's even more. This whole chapter is pretty much we're gonna learn some shortcuts. Okay? Questions on this one? Alright, then let's look at the sum and difference rule. Okay? Try to see if this makes sense to you, this verbiage. The sum and difference rule says the derivative of a sum is the sum of the derivatives. Right? The derivative, this is a function that's the sum of 2 functions, right? So the derivative of the sum is just the sum of each of their derivatives.
Kind of like the limit.
Yeah. The limit of a sum is the sum of the limits. The derivative of the difference is the difference of the derivatives. So basically, whenever you have like a polynomial, you can basically take the derivative of each term separately and just add them together, which is very, very convenient, right? Can you imagine how much easier this is compared to finding the limit of all of this, x plus h squared plus 5 times x plus h plus 3 minus x squared, and it's, oh, no, okay? So,
Yeah, 'cause for every h we have to plug in x.
yes. So now let's do this one piece at a time. So what's the derivative of 2x? Oh, sorry, derivative of x squared is 2x. What's the derivative of 5x?
5x.
No. Just think about it. What's the slope of 5x?
5.
Okay, what rule is that? The second one, it's the second one and the fourth one kind of combined, right? The second one tells you the derivative of x is just 1, right? And then the derivative of any of that times a constant in the front, you just multiply by that constant, right? So the derivative of x would have been 1, but you have to multiply by 5, right? So it's just 5. Okay, and what's the derivative of 3? 0. Okay, so when you see that extra constant, you're just going to learn to ignore it when you're finding the derivative. Yeah, so the derivative is just 2x plus 5. That's the answer. Okay? Yeah. So I told you we're not going to be doing limits all year. We still have to understand it. There's always a twist. True. Okay, let's do B. How do you do that? What's the proper notation? That's f of x. So the derivative, how would I write it? F prime of x, or I could do df dx, but okay, let's just do f, but that's easiest. Okay, what's the derivative of x to the 4th? 4x cubed. Okay, minus, what's the derivative of 3 over 2x to the s cubed?
3x.
You're going to multiply it by 3, so it's going to be 9 over 2, negative 9, or minus 9 over 2, yeah, times x squared. Okay, what's the derivative of 2x squared? 4x. The derivative of x?
1.
The derivative of minus 6? 0. Yep. Okay, so right now work with your partner. I'll give you guys 4 minutes to do C, D, E, and F.
Will there ever be like terms that we have to combine?
Yeah. You could combine the like terms and then find the derivative, or you could find the derivative of each and add later. It doesn't matter. Sum of the difference is the difference of the sums. Or, no, that makes sense. Okay, come on, let's go. Monday.
Okay, I got lost.
Let's do after school one more time. Okay. Yeah. Wait, negative x? Uh-huh.
Does this already apply to this?
Yeah, so then it's going to be
Positive?
Yeah.
And then this one is
Bring it up. So
will be negative 12x.
So you guys are working on this on your own, and you could check your answers up here as you see fit.
get negative 4x negative 2 minus no plus
Wait, why is the x
plus
the negative 3?
The negative one?
For C.
For C, because you bring the negative 2 and you
get
multiply
this?
by negative 4.
Oh yeah, you can. Okay, you multiply by negative 1, that gives you negative 8.
Yeah, and then
So it becomes positive.
x cubed.
Then the old negative 2 minus 1.
yeah, x cubed and then minus 12x to the negative 4.
Oh. We have to do what?
Yep.
We distribute it?
Yep.
So we're gonna be 6.
Can't you do the thing that like you just leave it aside?
That's only for constants.
But isn't 6 a constant?
Yeah, you could do that with 6.
But you would have to.
But you still have to distribute the x's. But I'm not going to do that. I'm just going to combine them all. And do the constant rule later. Yep. I'm going to distribute and then find the derivative of each part.
Oh, so distribute 6 square root.
Yep.
So then if you distribute the radical to another radical, does that
You have to add the, if it has the same base, you add the exponents.
So it'd be 2x.
No, what's 1/2 plus 1/3?
Oh, like that.
5/6.
1/2 plus 1/3.
Okay, so let's stop after D.
So 6 next. Scissors. 5 over 6.
If you can get D, then you can stop right there.
So that's gonna be 1/2. But then that's 1. So then it's gonna be 3 over 2.
You have to distribute the x.
30 divided by 6. 36 to the 1/2. Yeah. And then this is y prime. Oh, okay, so you get y. So then that also goes. Okay. So then you kinda oh, because then you gotta do the whole. Okay, so then you gotta bring this to the front. And then that's 30 over 6 is 5, so that's 5x. Yeah. And now you gotta do the whole thing. Oh, yeah. Yeah, that. Minus 1. That 5x is negative 1/6. Back. Oh. Why? That's not a T. Oh, that's not 6. Okay. Oh, okay. 36.
Not small. Thank you.
Subtract 1. Another 1/2. If you subtract, how does she get? Miss Han? Yeah. If you for negative 18x, if you subtract 1 over 1, that's gonna be 2 over 2. So then you would get 1 over 2. Yeah. 1 over 2. Then they will cancel out.
The last one or the
No,
first
the
one?
first one. Because if you subtract 1 from the exponent,
Here?
yeah, you would get 1/2.
Oh yeah, where did I get that from? I thought it was negative.
So they cancel
Is it
out.
negative? No, it was never negative, right? Oh, okay. Okay, yeah, you guys are right. So if I subtract 3/2 minus 1/2, I'm just gonna get, minus 1, I'm just gonna get 1/2, positive 1/2, right?
And then those will cancel out. Yeah, equals 5x. Wouldn't it have to be negative 1/2?
Isn't that right?
But the last
not
two
the
wouldn't
same.
cancel.
Oh, that's the negative one.
You guys can keep going if you're done. More practice never hurt anyone. Never. 36?
Times, say 1 over 3.
Where's 1 over 3?
For the very first step?
I'm not multiplying, I'm adding the exponents.
Oh, you add them?
Right? Because x squared times x to the cubed would be x, 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 x. Be 5 x's, right? We add the exponents. So to clarify, x square root of x is x to the 1/2. Cubed root of x is x to the 1/3. Okay, and then when I distribute this multiple out here, x to the 1/2 times x to the 1/3, they have the same base. You have to add the exponents. So it'd be x to the 1/2 times x to the 1/3 is x to the 1/2 plus 1/3. Half is 3 over 6. 1/3 is 2 over 6. 3 over 6 plus 2 over 6 is 5 over 6. So you have 6 times x to the 5 over 6. And then 1/2 times x to the 1. This is really x to the 1 power. So 1 plus 1/2 is 1 and 1/2. That's where I got 3 over 2 from. Once I have the expression distributed, then I could find the derivatives of y prime is, and then I use my product rule. I mean my power rule. So far all we know is how to deal with the sum, the derivative of a sum. So to use our sum rule, we have to distribute everything so we can just have like a polynomial, straight up polynomial expression. Yeah, you can expand it. It would distribute, yeah. No. That's a good question.
4x squared.
That's a good question. Arlene said, can't you just bring it to the front? We will learn something that will help us do something like that. We'll learn another shortcut, but for now, all you know is the sum and difference rule and the constant rule and the power rule and the constant multiple rule. So with the rules that we know, the only thing we can do is first expand this, right? We cannot just put the power in the front, no. Because that only works for x to the certain power. So then we're going to distribute that. So f of x equals 4x squared minus 12x plus 9, and so f prime of x is going to be 8x minus 12. Right? Okay. Did everybody raise your hand if you are done with D already? Raise your hand, please, if you're done with D. So say you're still working on D?
Oh, no.
Brittany, are you done with D? Yeah. Okay. Are you done with D? No. Okay, cool. Alright.
Oh, for this one.
Keep going. Who's hat? Who's what?
Huh.
Oh.
Can't we just simplify the middle and then square them? Then you'll just get the same thing.
What do you mean? You mean by the derivative and then square?
No, if you like factor the middle, factor the front.
Oh, is it? Can you factor it? Is that factorable?
X squared minus x plus 1.
X minus 1 times x minus 1. No.
Oh man. Wait, yeah.
No, it's not.
So for the last
Oh, negative
one,
1/2. No, never mind.
for the last, wouldn't it be so much easier if we didn't have to do that?
Can you cancel
Wouldn't
the
it be
squares?
easier to have another rule?
Yeah. Survey says.
You still want us to do
Yeah, keep going.
Are you gonna lead into something? Oh no.
Yeah, that is
Secret
it.
to math.
Attention team, this is a fire drill. Please calmly and quickly evacuate classrooms and line up on the blacktop. Account for all students by taking roll and holding up the correct signs. Middle school teachers, please turn your walkie-talkies to channel 4.
Your math book.
How?
Just kidding, you don't have to. But you should. Actually, that'd be so cool if we were all standing out there in a line just doing that.
Oh my god!
What?
How do you use it?
They're all
It's wherever you see that, you use the rule that it's
Yeah.
So it's not
They're
one
all
rule
kind
for
of the
it.
same.
It's, yeah, the,
I like the.
Once again, this is a fire drill. Please calmly and quickly evacuate classrooms and line up on the blacktop. Account for all students by taking roll and holding up the correct color sign. Middle school teachers, please turn walkie-talkies to channel 4.
Turn them off. Come here.
At least a pass.
Stay outside.
I'm burned.
I should probably be like, come on, we're gonna have time. Bring it down. But it's like just that.
Now we're on fire!
What do you want me to look at, babe?
Yeah. How far did you get?
Alright, that's the product rule. When you have the derivative of the product is not the product of the derivatives.
Not?
Okay, so the derivative of a sum is the sum of the derivative of a sum is the sum of the derivatives, right? We could just break up this function and then find the derivative of each part and add it. You can't do that with products. The derivative of a product is not f prime times g prime. So it's f times g prime plus g times f prime. So let me write that in an easier way for you.
You just square it.
No.
You can't.
No. Okay. Okay, so let me say it again because it wasn't recorded. The product rule. So the derivative of the sum is the sum of the derivatives, but the derivative of a product is not the product of the derivatives. It's a little bit more complicated. The derivative of the product of two functions is the first function times, it's the first times the derivative of the second, plus the second times the derivative of the first.
Okay, now.
Okay? Yes.
So then, based on the associative property.
Associative property, yeah?
Can't it doesn't matter really the order which they're multiplied in? Like can't
No,
you
you-
just add the same one twice?
No, but it's not the same one. These are four different things. This is f, g
Oh.
prime, g, f prime.
They were all
Oh yeah, I thought it was.
No, this is plus. So you have two things here. You have this
Right.
plus this. Now here is how what I taught you guys. So let's sing it together for Mario. Okay. All right, so repeat after me. Derivatives, so just sing derivatives. They help us find the rate of change. Derivatives, derivatives. That's not too hard, it's in our range. The product rule is so much fun. It's 1d2 plus 2d1. Derivatives, derivatives. They help us find the rate of change. Okay? No. All right, one more time. Loud and clear. Derivatives, derivatives. They help us find the rate of change. Derivatives, derivatives. It's not too hard, it's in our range. The product rule is so much fun. It's 1d2 plus 2d1. Derivatives, derivatives. They help us find the rate of change. Very good, very good. All right, so now what does that mean? Okay, so,
That's scary.
all right. So if we have two functions, whoa.
400s.
If we have two functions, let's just call this 1 and 2. Now I'm not saying this is a value of 1 times 2. I'm not saying that. I'm just saying if that's the first function and the second function, then the derivative is 1 times the derivative of the second one plus the second one times the derivative of the first one.
It makes perfect sense.
So the product rule is so much fun. It's 1d2 plus 2d1. Get it? 1d2 plus 2d1. 1d2 plus 2d1. 1d2 plus 2d1. 1d2 plus 2d1. Okay? So now let's actually try it. Normally, without the product rule, we would have to go, y equals, we have to distribute and do all that, right? Distribute. But ain't nobody got time for that. So we're just going to skip to using the product rule. It's much easier, right? So it's going to be, y prime is going to be the derivative of the first part. Oh, sorry, 1. Yeah, 1, which is 4x minus 2x squared times d2. What's the derivative of the second part? 3x minus 5. The derivative of 3x minus 5 is just 3. Yeah? Plus 2, which is 3x minus 5, times the derivative of the first. What's the derivative of 4x minus 2x squared? 4 minus 4x. You guys see that? And now we can distribute, but it's just a lot simpler.
12x
Okay?
minus 6x squared plus 12x minus 4x.
That's what I got.
Could we still do it the other way? Like the low way?
If you want, be my guest, yeah. In fact, you could use limits if you want. You could do f of x plus h minus f of x over h as the limit as h goes to 0. And you can always use your calculator to check by plugging in a value maybe.
In the AP test, will they ever ask us to use the limit? Like specifically ask us?
They're probably gonna, no, what they would do is like, they might give you a multiple choice one and say which limit like gives, is using the like which derivative is using the definition of the limit, and they'll give you like, they'll mix it up and they're like, oh, the limit as h goes to 0, the limit as x goes to 0, the limit as h goes to 1, and you have to like,
H goes to 0.
Yeah, well that's but there's also the alternate definition which you have to know.
Actually,
Symmetric
x
difference.
goes to a.
And then there's a symmetric difference,
You have
quotient, the numerical derivative,
Remember those?
Yeah, it's in that
Symmetric?
page.
Oh,
Yeah, it's symmetric. That's how your calculator does it. Remember?
Oh, the ender?
Yeah, so it's like f of x minus h, no, f of x plus h minus f of x minus h over 2h. You guys remember that?
Not gonna lie.
This one.
Can't hear it. Oh.
Okay? So keep those in mind. So that's why the outline will help you store all that information in your brain. Okay, so why don't you do one more? Okay, let's just do B with the product rule, and then we're gonna learn oh, look at the time. Okay, so yeah, you get that? Okay? Does that make sense? I mean, I know it's gonna take you a while to get used to how to use the steps. You'll be tripping. It's like learning how to ride a bike. You get the steps, but you're like still falling. But you keep practicing, and then you learn how to ride the bike without hands. All right, but now I don't have a song for this. There's a quotient rule. It's not 1d2 plus 2d1 for a quotient. The derivative of the quotient of two functions f and g can be found by using the following. The derivative of f divided by g. Okay, the way we say this is 1d2 over 2d1. Wait, 1d2 minus 2d1 over wait, sorry. Okay, it's like this. Lowdihi minus hidilo over low squared. Lowdihi minus hidilo over low squared. You go like this. Lowdihi minus hidilo over low squared. Okay, so this is low. Oh, no, sorry, this is low, and this is high, right? Lowdihi. Okay, it's the higher function and the lower function, right? So this is low d high minus high d low over low squared. That's how you're gonna memorize that. Okay. My teacher never taught me these tricks, so I just have to memorize it straight up. All boring. Okay, low d high minus high d low over low squared. Okay?
Yeah.
Oh my goodness.
Get it? Okay, so let's try this one. So this is the high and this is the low.
Students to go and take the pictures according to the list that you were given. Once again, you may not release the students to the hall. Thank you.
We have 2 more minutes. Alright, so the derivative. Okay, wait, I don't have to write that all over again because it's already written there. Right? So it's going to be, okay, what's the low? X squared minus 1. Low d high. The derivative of the high is 5. Yeah? Minus, what's the high? 5x plus 2. d low, the derivative of the low is 2x plus 0. That's low d high minus high d low over low squared. And we could simplify it, but we'll just leave it like that for now. Okay, you guys know how to simplify
Can we
it.
do this with that?
What do you mean?
No. Yeah, we can, right?
What do you mean do this with that? No, you don't have to find the derivative. You're done. That is a derivative. You're not differentiating anymore. You
So,
differentiate just
stop
once.
here?
That's it?
That's it. And then if I ask you to simplify,
It's not.
I mean, you can, you know, you don't have to. I mean, it depends. Like, it's not really about knowing the algebra, although sometimes you need to, but 5x squared minus, 10x squared minus 4x over, I don't have space, I'm just going to do x squared minus 1 to the negative 2. If you do that, make sure you do parentheses, okay? Okay. Yeah, it's fine. Okay, do B, okay? Do B. Doobie 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 doobie. Low d high minus high d low over low squared. You have to say it. That's the way it sticks.
Upside down.